Okay, here's a little dynamics problem for you. Let's say that we have a mass, M, big M, sitting on a frictionless table connected to a mass, little m1, uh, by a cable, a massless, extensionless cable, and another cable connecting to a mass m2. And we'll say that m2 is bigger than m1, and there's no friction here, so this whole thing moves to the right, or clockwise I should say. Let's say that M is equal to 20 kilograms, and I'm going to say that little m1 is equal to 5 kilograms, and little m2 is equal to 10 kilograms. So this whole thing is going to accelerate clockwise. And so what I want to find out is I want to find out what the acceleration is, and I want to find out the tension in the cords. The tension here, I'll call this one, let me write that this way, I'll call this one T1, T2, and this one over here T1. So I want to find out T1, and I want to find out T2. So how do I do this? Well, I set it up by looking at the forces acting on the system. Over here we have gravity acting on M1 down this way, exerting a force in this direction, which is little m1g. Over here we have another, we have the gravitational force. I'll tell you what, my pen is running out here. Let me get another one. So the gravitational force acting on M2 is M2 times G. Forces acting on big M, well, there's a gravitational force in this direction, big MG, and the normal force due to the table, just call it F normal if you want, although it's irrelevant because there's no friction. We really don't care about that. The mass is not accelerating or moving in this direction, in this dimension at all. It's just that T2 is bigger than T1, so the whole thing accelerates to the right. So how do we do that? So the easiest way to look at this is to look at the whole system, like all of this mass right here is being accelerated by the net force acting on the system. So let's see, these forces are internal, so they don't count, the T1 and T2. These don't count because they're in the wrong dimension. So I have M2G, which is larger than M1G, and I can write an equation like this. I can say M2G minus M1G is equal to the total mass, which is big M plus little m1 plus little m2 times A. And so A then is equal to G times m2 minus m1 divided by the sum of the masses, like this. All right, so if I plug that in, plug the numbers in, this is 9.81. M2 is 10 minus M1, which is 5, divided by the sum of the masses, and that's 20 plus 5 plus 10. And if you get your calculator and take a look at that, what you get is, that works out to be about 1.4 meters per second squared. So that's how you calculate the acceleration. All right, how about the tension, T1 and T2? Well, that's pretty easy because now that we know what the acceleration is, if we want to find out what T1 is, we just write an equation for this system right here. And this will tell us that since T1 is bigger than M1G, that T1 minus M1G, the net force acting on this mass, is equal to M1 times A, and that means then that T1 is equal to M1 times A plus G, and that's equal to 5 times 1.4 plus 9.81, and that works out to be, when you put it in the calculator, I'm saving a little time here, approximately 56 newtons is T1. What about T2? We can do exactly the same thing, only in this case, this is bigger, this force is bigger than this force since it's accelerating this way. So I can write that M2G, let me push it up a little bit here so you can see what I'm doing. M2G minus T2 is equal to M2 times A. It's the same A because they're all connected together and all accelerating at the same rate. So this means then that T2 is equal to M2 times G plus A. G minus A. G minus A. I moved A over to this side and T2 over to the other side. So I have T2 is equal to M2, which is 10, times G, which is 9.81, minus 1.4. And that works out to be, when you put it in the calculator, T2 comes out to be 84 newtons approximately. That's T2. Hope you can still see that. I'll move it over a little bit so you can be sure that you can see it. So that's what we were after. We're after the acceleration, T1 and T2. And that's one way to set that problem up and work it.